Okay, it's recording. Basically what I've been doing is I search up my topic on there, which is tectonophysics. So I just, in the search bar, tectonophysics, and then all the articles that are related to that show up. And then on the left side, you can narrow down your search so that you find more current articles. So I like shorten it to like 2000 to now. And then all I do is pretty much, hopefully he doesn't watch this in his recording. I pretty much just um, I summarize the abstracts, which are a summary of the article already.
Yeah, that's what I do, and I read the conclusion.
I mean, like, not all the articles, like, a lot of them are pretty interesting, like, that I find, but they don't post the whole article. It's like, oh, but you don't have a subscription to this journal, so you can't look at the whole article. I'm like,
they only give you the actual summary of it, and then they don't give you a link to anything posted online. So I'm just like, I can't use this now. I mean, I could, but I mean, I don't think I'd get it. So
yeah.
Yeah.
But I love ProQuest because it just cites it for me, too. I'm just like, oh, cite. And it's like, oh, copy and paste this. I'm like, perfect, thank you.
Yeah. I feel like peer-reviewed articles are really hard to use with research. That was really weird. My voice just cracked. I haven't had that happen since I was like 13. Anyway, so like they're just really hard to use, and I had a teacher, like my global climate change teacher was talking to us about like reliability of like research and stuff, and he was like, we went really into depth about how like reading and doing research using peer-reviewed articles isn't really reliable because like if our brains like don't really understand what it's trying to say, we're gonna like try and make sense of it, and like we might misinterpret it, which is typically what happens with those types of articles.
They're like not simplified at all. I had this in my last group. There's this older woman who I don't think really understood what the articles were about. So I like wrote, because he's like, yeah, comment on their summaries and their citations. That's all I do. I'm probably like a huge critic and people probably hate my comments, but I'm like, I don't even care. I just am doing this for points, okay? But I was also a writing TA for a year on campus, so I'm like really picky. Sometimes I put in brackets, I'm like, this is just me nitpicking because I was a writing TA, so like you probably don't have to worry about this, but you can change this if you really want. But there's this lady, it was like two sentences, or like, they wanted to know this, so they did this, but it's all this like crazy terminology that I'm pretty sure she didn't even know what it meant, because she kept all of that crazy terminology. So I was like, yeah, just as a reader, I think it'd be really helpful if you explain the terminology, because I have no idea what these articles are talking about, even from your summary.
Yeah.
well, I mean, like for the stuff that I was reading, like I don't understand the equations. I don't understand like some of the other general stuff that they were talking about. So I was like, okay, like based on what I've read and what I understand thus far, I think this is what it is. And I just left it at that. I'm like, that's the best you can really do.
Mm-hmm.
And like some of like the papers are like 20 pages long. I'm like, I have no time to read that, so I just read like the headings and the abstract parts, and then I
Mm-hmm.
read like find some random place in the middle to read some bits, and then I look at the conclusion and just see what they said, and then it's like, okay, summarize that.
Yeah.
Yeah.
Yeah. I sometimes when I like I just look at the abstract and I see like three things, I have like no clue. I'm like, no, never mind. Just like exit out, go find a
Yeah.
new one. I don't even want to try.
That's what I do. Like if I get like a couple of sentences into it and I like don't understand, I'm like, okay, not worth my time. I, it just, I don't know. It can get so frustrating to try and read those if you're like really trying to work it out and stuff. If
Yeah.
you like have no idea what they're talking about, it can get really frustrating. So I just don't even. Okay.
Yeah. I
Anywho,
believe that. Um,
so
uh,
Wee wee.
now, okay,
so I'm kind of confused. I honestly feel like we could do this conversation in 5 minutes kind of thing. Because that's like Google Earth that's up that I shared with you guys. But on our thing for this week, it says to work on plotting up the earthquakes that fall along a transect across the Marianas Trench and into the Sea of Japan. This activity requires a Google Earth file. I have no idea what Google Earth file he could be talking about besides the one we just downloaded for this week. But if you guys are looking at my screen, you can see the X's.
Uh-huh.
So, sorry. I don't know why they're X's, but they are actually like major earthquakes that have happened. So this is like a magnitude.
Magnitude 9. That's
These are all mostly magnitude 8 and bigger. So this happened since 1900.
wow.
1969.
It's scary to me how active it is over there.
Yeah. Okay. I was looking.
Saying that because, sorry, I interrupted, but like,
No, you're
are you
good.
saying that because you actually live in a place where you don't normally have earthquakes? Because if you lived in a place, like say Japan your whole life, would you really be scared?
It'd be pretty. So like, but that's funny you mention that because I was thinking of natural because of like my post. I'm like, yeah, I'm like not affected by earthquakes like at all. The only earthquakes we get around like near me are because of oil fracking, like a few hours away. But I've never felt an earthquake like living in northern British Columbia. But sorry, I have a cold. But wildfires. I'm used to them. They happen so much because it's so dry and there's so much forest, like firewood for these wildfires. I'm just used to those. So like for me, that's not like it's still sad and awful and can kind of be like scary when they come near your house because they'll just like destroy everything in their path. But it's not like weird for me or like super like, oh my goodness, a fire. It's like, not another fire, dang it, there goes my whole summer kind of thing.
Because you're used to it.
Yeah.
So I feel like, yeah, for like, people in Japan would be like, oh, another earthquake, dang it. Not like, depending on the magnitude though.
Yeah. Yeah.
I'm just going to get a drink of water real quick, sorry.
Yeah, take your time.
No problem.
Why did they
But
choose
it's
it?
just like, but I was like looking at this though. Like right by the trench, there's these little islands. If you zoom in, you can see people clearly live there.
Huh. I bet they have some freaky fish near where they live.
Yeah, I was
Fish
thinking about
live
that
near
too.
trenches.
No, but the thing is, so freaky fishes just live very deep in the water. They will rarely come up to the surface.
Sorry, say that one more time. I couldn't hear you.
Like the fish, they would rarely come up to the surface if they're living that deep. I mean, I remember seeing one time there's this one fish. I don't know if it was a sunfish. Yeah, I think it was called a sunfish, and it's like this giant looking flounder / parrot looking fish that like just lies on its side to like at the surface just sunbathe a bit and then it just goes back down. I don't know if it's real or not, but yeah. Hold on, let me look it up.
Huh. So did you say you're from China?
I'm from Hong Kong, but yeah, I guess you can call it that.
Okay. So isn't Hong Kong in China?
It's not in, it's like just at the edge of the Pearl River Delta, so it's like along the coastline.
Okay.
Because your governments are pretty separate, huh?
Yeah, that's thanks to like the British colonies and whatnot. Good old Britain, you know, leaving a mess.
Okay, he's not here yet.
Like they left the system incapable of like being self-sustaining for like the long run, and everyone was really reliant on like the people that were actually running it at that time. So like I feel like it just left things in a very bad shape, and like it's hard to explain, but yeah.
Huh. That's really interesting.
Yeah. And so there's also this handover thing that went on like in 1997, and so that's when the 100-year thing ended for Hong Kong. So then it was actually transferred back to being part of China.
Hmm.
And so because it
So
was already
interesting.
because they had a pre-established government there, some like this democracy kind of thing. It's typically known as like one country, two systems kind of thing for Hong Kong.
Huh.
It's the
So-
same with Macau, actually, but instead of the British, Macau was colonized by the Portuguese.
So in Hong Kong, do you feel like a lot of earthquakes?
There's no earthquakes.
You're not close enough?
Nope. I mean, we have typhoons, which is fun. Yep. And the occasional landslides, but that's about it.
Yeah. So are typhoons like hurricanes?
Yeah. They're pretty much hurricanes, basically.
Yeah.
Where
Yeah.
hurricanes, I would say hurricanes are a lot more severe. I don't know how to compare it to like typhoons, because in terms of size, they're probably not as big as hurricanes itself, but they're basically the same thing.
So yeah, a typhoon and hurricane are actually the exact same thing, but we just use different terminology depending where we are in the world.
Well, general
It's kind of
hurricanes
like
are
a
actually a lot
cyclone.
bigger.
Wait, yeah, pretty sure.
Nachos?
Later.
Huh?
Meeting with my group.
Nachos is so good.
Nachos with like cheese sauce.
So, got some nachos? I'm like, yeah, later. She's like, well, sir. I'm like, meeting with my group. She's like, I'm sorry, everybody.
That's awesome.
Yeah. Okay.
Okay.
Yeah.
So it says, as a group, synchronously, that happens a lot lately, work on plotting up the earthquakes that fall along a transect across the Mariana Trench and into the Sea of Japan. So, can you guys see my mouse? Okay, so I think it's meaning like this. Like, from the trench and into, right? It's talking about this.
Yeah.
Against the distance along the surface. I don't even know what that means.
Yeah.
Grant,
And note the size of the earthquakes as well. Well, size, we already know that because they already marked by X, but
Oops, don't care. They plotted it for us. So I think that I can probably just take a screenshot.
by distance, are they wanting us to do connect the dots with each mark of the earthquakes, or like what? Because we know how bad the magnitude of the earthquake, but they want us to do like the depth right now.
So the depth is the color here that shows here.
Yeah.
So there's the depth, and so we have, oh, these are way deeper in the sea than along the trench. It's interesting.
oh, that's really interesting.
Do you think that's partly because the oceanic plate is subducting under the continental plate, so that's why like that part right just over on the west side of Japan is like where everything's melting and actually breaking
That's so
Yeah.
smart.
underneath.
Because if you
Totally.
think about it, that's where the volcanoes would be erupting too, is along here. So it makes sense why the earthquakes are here and not like over here.
Yeah. Yeah, because all the action is happening there right under that continental
Ask
plate.
Jerica. Yeah.
Are you sure? I just want literally a slip, like a
Okay, I'm gonna take a screenshot of that,
want to try it right here.
and then
Yeah. Okay. Geez.
oh, copy and paste it.
Can I go make one with you?
Plotting up the
Perfect.
earthquakes all along the transect across the Marianas Trench.
Oh, okay. Protein. Do you like protein? You don't like protein. You have to like protein.
Plot the depth of the earthquake against the distance from the surface.
Also, Jerica, you walked by my window the other day and I was running out my house.
So
So the distance from the surface like the depth. So they're deeper in the Sea of Japan.
further west from the trench they get, the deeper they get.
Yeah.
It says for the same like bullet point, it says, and note the size of the earthquakes as well.
Okay, so magnitude. Oops.
But it says it's like the magnitude, eh?
But don't
So
the
even though this is deep, it says a 4.2, and then this,
Right now. No.
they're all around like a, that's a 5.
maybe because those ones are like right along, like you know how the X's that are really deep are like right along the trenches?
Yeah.
Maybe even though they're like more shallow, they're like
Look at that up there.
like maybe because they're shallow, we feel the jolt of it more. Does that make sense?
Like, are you talking about shallow waters kind of thing?
No, like how deep the is it the focus? Is that what it is?
Yeah.
The
Or
focus?
the epicenter.
Oh, okay.
Epicenter.
I'm just curious to know. Oh, depth 32 kilometers. So like those aren't. Yeah, it's interesting because even though the magnitude was so high, they're not as deep when they're next to the trench.
I guess it depends what type
25.
what scale did they use?
Do you think? Okay, so I think it's probably shallow because it's a continental crust adjusting itself over the oceanic crust. It's not as much of like them actually doing anything. It's more of like the oceanic crust buckling or folding itself or like there's softer, weaker parts inside the crust itself. So that's where like that's where you come with the shallow epicenter kind of stuff and whatnot for the earthquakes.
Okay. So the next question is, what trends do you notice of data? So I'm just writing down all this. So the
There
deeper
are a lot more frequent earthquakes just on the left side, like just outside of the trenches.
on the, what's the, if there's a subducting plate, what's the other one called? It's just the continental plate.
Yeah.
You could say non-subducting plate.
Okay.
The less dense plate. I don't know. Let me see.
You could say the heavier plate, subducting. Heavier plate, lighter plate.
Mm.
On like Google, when it talks about the two plates, it says the subducting plate subducts beneath and adjacent oceanic plate. So they just
Mm.
called it the adjacent oceanic plate. If you're at all curious.
Okay, so I said the majority of the earthquakes are happening right on the adjacent plate near the subduction zone. I'll say at the subduction zone.
Right next to it as well. It depends
In
on-
high frequency.
yeah, that works.
And then the other data, the deeper earthquakes happen further away from the
Trench itself.
from the trench. Further away from the trench. And the shallow earthquakes are the ones occurring more frequently at the trench. Okay, so the deeper earthquakes happen further away from the trench, and the shallow earthquakes are the ones occurring more frequently at the trench.
Yep.
The the earthquakes, though, the earthquakes with the greatest magnitude though still shallow also occur
Right
the
next to the trench.
Yeah, right.
Right next to the trench.
to the trench. Cool. So how do we explain those trends?
Oh.
Well, it all has to do with this subduction, I would say. When the plates are starting to subduct, it's very shallow, which makes sense why the earthquakes would be shallow. And then as it continues to go, more of the action is like lower, and maybe that's why the earthquakes happen at a deeper point.
Oh, yeah.
So it makes sense that the earthquakes at the, we could say, beginning subduction points, beginning subduction zones are more shallow, since this is where the subduction process is most shallow.
Could it also be like the sudden gives of like the crust and stuff, like saying like shallower areas is like the sudden give and like fractures and folding whatnot that in the weaker areas of the crust while like friction.
Yeah.
Because we see a lot of that a lot just along the trench right there.
Mhm.
And they're quite shallow actually.
Can you repeat that?
Yeah. So what I was saying was like that the more frequent, shallower points along the trench is probably caused by like the weaker areas in the crust itself. So it's like breaking, collapsing, cracking, and like faulting and whatnot. So
So the more frequent shallow earthquakes are also happening near the most near the weakest
areas of the crust, yeah.
areas of the
Yeah, because if you think of it like a pie crust, you know, you have your weak areas and then you have the areas where it's like really solid and strong, and then like if you cut somewhere, you have parts that are just gonna give and whatnot. So
true. So we could say that it also takes less friction or tension
we're
to
forced to,
less force
yeah.
to break it.
I almost feel like some parts, like, kind of like when I think about it, and I don't know, this might not be accurate, but like, I almost think of it as like some parts are just more like brittle. Like some parts of the continental crust are just more brittle. They just like break more, and so it's like more movement happening. Anyway.
Yeah.
And like I don't know if you noticed, but then also like the deeper areas are actually where it's like in the ocean itself. It's not like on land or anything, and I don't know if it has to be because if it's deeper.
Yeah.
So like that area is probably a lot more denser and deeper itself because it's like underneath the ocean.
Take a photo of the meeting that we had first, for like how many rooms we had.
I don't know. I have to check. I don't remember if I did.
Okay, our explanation for the what's it called? The bigger earthquakes. The high magnitude ones. Do we need to add those? Oh, we took a picture of it, so we should probably give a small explanation.
What do we have so far? What's on?
Okay, so explanation for the trends. It makes sense that the earthquakes at the beginning subduction zones are shallower, since this is where the subduction process is most shallow. The more frequent shallower earthquakes are also happening near the weakest areas of the crust, taking less force to break it, causing a shallower product, I said.
Cool.
Yeah, it sounds pretty. That sounds pretty.
So you're wondering, like, should we say anything about like the earthquakes that are in the Sea of Japan?
Yeah, we should. So, so we could just add it on to that first point, about like the beginning subduction zone stuff. Maybe like
It could be like where that, like, you know, the crust actually starts melting, and because of that, you actually have areas where like things just break off from the actual crust, and then probably that vibration just transfers upward to the crust itself.
But you have to get pretty deep before it starts, you know, like melting, and that's probably why they're deeper.
But I feel like when we look at it, this is just when they actually start melting and breaking off from the actual crust itself. Because like if you go like right under Japan, it's probably where they actually have where it just goes down and fissures and whatnot. So then you have the all the islands being formed because there's fissures that shoot up. But then we're talking about like actually breaking off maybe, so it's like further inland.
Yeah. Yeah, I agree.
Solomon Islands. What about the Himalayas?
Okay, so the deeper earthquakes happening in the Sea of Japan could be occurring because of the depth of the tectonic processes, in brackets, subducting and melting.
That's a good enough description, actually.
Well, okay. So what would you expect to see if you went further inland? Into
I would expect
China, I
to
guess?
get deeper
Mm.
and
Is that,
not as strong.
that's Russia though, isn't it?
Yeah. Peter the Great Gulf, that's Russia.
Yeah, I saw it. I was like, well, there's Korea.
Yeah. Korea doesn't really have any like volcanoes and whatnot.
I mean, like, I feel like it would just stop. I mean, it does, but
Okay, but funny enough, actually there are certain areas in China itself where they actually do have earthquakes. And I was just like thinking, how come?
Mhm.
I remember there's like this one area, I forgot which specific area that actually they have a lot of frequent earthquakes. And so I'm just like, why? I don't remember why exactly they have that.
Let me pull up my faults. Does that work? I don't know if that's only in the United States though.
List all my faults.
Where is the United States of America? Oh yeah, it's only in the United States. There's some faults.
I have to go and pick up my husband in like 5 minutes. So
Okay.
just a warning.
Yeah, if you need to leave, it's all good. We can finish the last couple of questions. So the last two questions are, what would you expect to see if you went further inland, and what would you expect to see if you did the same thing along the trench near the Solomon Islands, and what about the Himalayan mountains? This is also about to end in 2 minutes, so we'll have to start a new one. But
Okay.
if you need to leave, it's gonna be all good.
I'm good for a few more minutes. So just warning y'all.
You're good. Instead of that one. Oh, sorry.
I feel like if we went further inland, I think it would continue with the trend, and so like the magnitude of the earthquakes would become so little that it wouldn't be felt. And then like eventually,
Even if they were happening deeper.
yeah.
Okay. That would
That's
make sense to me.
I remember when I was a kid, I read from somewhere that like there was this theory of say if there was like a very serious earthquake, and because you know how like I don't know how viscous things are, but like you know how vibrations can be transferred through water.
Yeah.
Like possibly like you know say like Haiti, that was like a serious earthquake. Maybe it could like it transferred through the magma underneath, and then it like caused another earthquake somewhere else.
Oh, I think it does like it can send like
The
I don't know.
shockwaves.
Yeah, I feel like it can send like shockwaves or like some sort of like
Residual like
yeah, like stuff through the through the earth to like opposite sides. I feel like I looked at data that was like analyzing that at some point.
yeah, because like the magma is like water, and so if you can actually do that with water, it should definitely do that. But like, yeah, that's what I was just thinking. So,
Yeah.
and like that's probably why in like some certain areas where there's no actual plate tectonic activities, you still have like random earthquakes maybe, and so I'm not sure if that's because of that.
Yeah. There's also like man-made causes
Oh yeah,
too.
like drilling oil and yeah,
Yeah.
dredging and whatnot.